Good morning, everybody. So this is the way we are going to do the notes for this section, hopefully. I'm going to drop into screen share, but you'll see my little face, probably my children at some point. We are going to do the notes for the end of 5.3 this way, as well as 5.4. And then in the email that has this video, there is an assignment, and it will be for a quiz grade, which some of you guys need. So please watch the notes, do the assignment, and we will meet again on Thursday. I'm going to switch to screen share. Somehow. Sorry, it's always good except like this. Where is it? Oh, there it goes. All right. So I want to share this. All right, so you should be able to see my screen now with the notes in 5.3. This is just partway through the notes. This is where we left off last week on Thursday. So the least common denominator of two or more rational, I'm going to get my pen here. Two or more rational expressions is defined as the least common multiple of the denominators. Okay, so we have done least common denominators for regular numbers. This is where we ended the other day. Least common denominator was 12. Okay, or we did like 1/4, that's a 4, sorry, plus 1/8, and found the common denominator there. It's the same idea. It's just using rational expressions that have variables. So first, always first, factor everything. Because if you don't do this first, finding the least common denominator gets significantly harder. So don't make your life harder. The least common denominator is the product of the unique prime factors from the denominators to the highest power in which it appears in any denominator. So basically what you do is you look around, you go like, oh, I got one of these, I got one of those, I got two of those. That's what I need as my least common denominator. You take all the pieces and make sure they're accounted for. So for example, here is this is just plain old numbers. What's the least common denominator of 12, 18, and 30? So you've got to pause and think. I'm going to turn my page. Well, I know it's not anything smaller than any of these numbers, right? So think about what the choices are. Well, I could use 60, but 18 doesn't go into 60. I really have to count by the biggest number, right? Count by 30s. Could 90 work? Well, it would work for 30, but not anything else. 120 would work for 30 and 12, but not 18. 150 only works for 30. 180 would work for 30, would work for 18, would work for 12. Okay, so let's make least common denominators. Let's turn them all into 180s. Remember the process for this. Takes a minute to write with the silly marker on here. So to turn a 12 into a 180, I'm going to multiply by 15. So multiply the top and the bottom by 15. That's going to make that 15 over 180. To turn an 18 into a 180, I'll multiply by 10. So multiply the top and the bottom by 10. That's going to turn that into a 50. To turn a 30 into a 180, I multiply the top and the bottom by 6. So 7 times 6 is 42. Okay. So in each of these cases, all we did was find the least common denominator, make equivalent fractions. Okay. So let's do that for something rational. So here we have x's, y's, z's, and numbers. So take them one at a time. So look at the numbers first. I have a 2 and I have a 16. Well, the least common denominator can be one of the numbers, and 2 can turn into a 16. So 16 is a multiple of 2, so I'm going to use 16. Let's see, x's. Let me change color. I have 3 x's here and I have 1 here. So you use the most of what you have in any case. So that's going to be x cubed. Let's look at the y's. I have a y here and a y squared here. I'm going to use the most, so y squared. And then this guy doesn't have any z's, but that guy does. And if any one person has part of it, you got to use it. Okay, so that is my least common denominator. That's all it is, okay? To change these into equivalent fractions, though, I have to use that. So how did I change this first fraction? Well, I turned a 2 into a 16. That means I have to multiply by 8. X cubed is the same. Y, I have an extra y, so I need an extra y, and I have a z. So 8yz, the top becomes 8yz. The second fraction, let's see, 16x cubed y squared z. How did it change? Well, the 16 didn't change. X became x cubed, so that's an x squared. Y squared is the same, z is the same. So all I did was multiply 5 by x squared. That's it. Those are my equivalent fractions. So let's try another one. The numbers I'm not worried about, but if you'd like to try that one, I can uncross it out and you could try it. My pen back. Let's do this one. So stop, pause the video, try it, okay? So stop and look at the numbers first. Least common denominator of 18 and 9 is 18, so I'm going to use 18. Look at the A's. The most A's is a to the 4th. That's my guy. The most B's is b squared. That's my guy. So the least common denominator here is 18, a to the 4th, b squared. Okay? So now change each fraction. The first fraction, 18, 9 becomes 18 because I multiplied by 2. A to the 4th, let's see, I had a cubed, so I need one more a. And b squared I had, so 1 times 2a gets me 2a. For the second one, 18, that's the same. A to the 4th, that's the same. B squared, I just need one more b, so multiply by b. That becomes 5b. That's it. Okay. This gets a little more complicated when we got stuff going on, right? So when always the first step is to factor. So take a look at what you have here, okay, and think about how to factor it. Well, take it one piece at a time. I know I don't have to do anything to the 6. And the x squared plus 3, that's a sum of a, that's not a square, it's a sum. There's nothing to factor there. Okay, so that's actually prime. I'm going to leave it alone. X squared plus 9x plus 20, I need to multiply to 20 and add to 9. So 4 and 5. X plus 4, x plus 5. All right. And then for the second one, x squared plus 8x plus 16, I need to multiply to 16 and add to 8. That'd be x plus 4 and x plus 4, right? That one is a perfect square. So now we got to look at what's in the denominators. So I have an x plus 4 and an x plus 5 here, and I have x plus 4 and x plus 4 here. So I need each unique thing the most number of times it occurs. So I'm going to need an x plus 5 because that's floating around out there. And then I'm going to need x plus 4 twice because if I don't use it twice, I won't be able to get my full denominator for the second fraction. All right, so that's my least common denominator. Now, so let's put our first fraction. Ooh, I lost my pen. Hold on. Yeah. Let's put our first fraction there. So how did this denominator change right here, this first one? Well, I needed an extra x plus 4. So what I would do is take my x squared plus 3 from the top, multiply it by x plus 4. That's it. You would multiply through. I'm not going to do all that here because you see I'm going to run out of room, but it's just FOIL, right? Let's do the second one. The denominator is going to be x plus 5, x plus 4, and x plus 4. Oh, I forgot the plus. How did this one change? Well, the new thing here is this x plus 5, so I'm going to do 6 times x plus 5. That's it. Okay. Let's try another one. Excuse me, my brain's not quite ready today. This one's a little strange, right? So I have x plus 4 over x minus 3 and 1 over 3 minus x. We talked about this a little last week. These guys are not the same, right? But they're close. So what I can do is take this second one, or whichever one you want, and take out a -1 from the denominator. So if I take 3 minus x, and I pull out a -1, that switches everybody's signs, which means I can rewrite it as x minus 3. Then I have a common denominator. All I did was change a sign. So this guy can stay the same because x minus 3 is the denominator. This guy, the second one, all that changed for him is I made a -1, x minus 3. Those are my favorites because they're the easiest to do. All right, so pause the video, try these two all on your own, and then unpause it and come back. So let's do this one. So let's look at the denominators. Let's see. Factor the first one. I need it to multiply to 4 and add to 4. That's probably, let's see, x plus 2 and x plus 2. I don't need to factor the 5. Let's look at the second one. X squared minus x minus 6. I need to multiply to -6 and add to -1. So let's see, I would bet that's a -3, x minus 3, and a plus 2, x plus 2. So now look at your factors. I have an x plus 2, an x plus 2 here. Over here I have an x minus 3 and an x plus 2. So what do I need? I need the most of each factor, and everything has to be represented. So I need two x plus 2's, x plus 2, x plus 2, x plus, oops, sorry. So I got two of them, and then I need x minus 3. So look at the first fraction. If that's the change I made, the new thing is the x minus 3. How does the numerator change? Well, I'm just going to multiply it by x minus 3. Do the second fraction. So x minus 3, x plus 2, and I need an x plus 2. How did this one change? Well, it was that extra x plus 2. So x plus 1, oops, times x plus 2. There it is. All right, you can multiply the tops through. You should. I'm not going to right here, but you guys know how to FOIL. All right, look at the second one. So you can see there's that mismatch right here. I'm pointing at my screen like you can see that. They're just opposite signs, right? So I'm going to pull a -1 out of the second one. If I pull a -1 out of z minus 7, it becomes -7 plus z, which then becomes z plus 7, hooray, or z minus 7, sorry. It's a little early here in my household. So forgive my slow brain sometimes. Z plus, yes. Okay, get my signs right. I was right the first time. So the first fraction stays the same. The second one just becomes a -1 over z minus 7. Done. All right. So equivalent rational expressions is really just making the denominator common. It's what we've been looking at the last couple of steps. It's just sort of laid out here. Okay, so I want to turn 5p squared into 20p to the 6th. What do I do to do that? Well, I have to turn 5 into 20 and multiply by 4. I have to turn p squared into p to the 6th. That means I need p to the 4th. So multiply now. 7 times 4p to the 4th gets me 28 p to the 4th. You don't want to simplify this here because the goal was common denominator. Okay, so remember the whole point here, if you simplify, we get back where we started. We lost our common denominator. Leave it alone. Try this one. So w over w plus 5 can turn into this somehow, right? Well, that just means that w plus 5 is one of the factors here. So let's factor this and find out what we're missing. I need to multiply to -10 and add to 3. Well, I know one of them is going to be, I didn't make this big enough, w plus 5, right? Plus 5 and minus 2, w minus 2. So the thing that's missing is this w minus 2. That's what I'm going to multiply by. So this becomes W times W minus 2. That's it. Okay. All right. So pause. Try these, please. Okay. You're back because you tried them. I know you did. You did. All right. So how do I turn 8xy into 16x cubed y squared? Well, I need to multiply by 2 to make 16. I need 2 x's. And I need 1 y. So 1 times that gets me just that, 2x squared y. All right. Now I need to turn 5b over b minus 3. What is this? This is a difference of squares, right? So it's just b minus 3 when I factor it, b plus 3. So what's missing? I have a b minus 3 already. I need the b plus 3. So what I'm going to have up here is 5b times b plus 3. That's it. Okay. All right. So now that we can make common denominators, we can add and subtract. Beginning steps are always the same. Factor, 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 factor. Hi, factor. Identify the least common denominator. Write equivalent fractions. Add and subtract the numerators. Simplify if you can. Okay, we're just adding the add and subtract and simplify steps into here. The first 3 steps are what we've been doing the last 10 minutes. So first, factor. Nothing to factor, right? Okay, so let's look at least common denominator. Well, I know I have to use a 7 because this guy has one. And the most b's is b squared. So that's my least common denominator. I'm going to make equivalent fractions. So let's see. This guy I need to multiply by b, so that becomes 3b. This guy I need to multiply by 7, so that becomes 28. So then I get, add them together, add the numerators. B plus 28 over 7b squared. I can't factor a 3 out of the top because 28 is not divisible by 3, so leave it alone. You cannot cancel things when they're attached by an addition like this, so I know you'll be tempted, but don't do it. Okay, let's try this one. Pause. Try it. Have some tea. It's still really early. Okay. So common denominator. Well, I need a common denominator for 5 and 3. Neither of those is going to work. 15, right? So let's use 15. And the most y's is cubed. So 15y cubed is my common denominator. Now I have to make equivalent fractions. So the first fraction, I have to turn a 5 into a 15. That's times 3. And y into y cubed, that's y squared. So 4 times 3y squared gets me 12y squared. For the second one, I need to turn 3 into 15. That's a times 5. And I already have y cubed, so that's fine. This just becomes 5. So now add the numerators, 12y squared plus 5 over 15y cubed. I can't, there is no common term between 12 and 5. It's done. Leave it alone. Right? A little more complicated. So now we do need the factor step. So factor. Okay, factor anything that needs to be factored. This first numerator, there's nothing to factor there. Okay, nothing common. Like way off my pages on my notes here. There we go. The denominator is going to be, let's see, multiply to 12, add to 4, multiply to negative 12. So t, let's see, plus 6 minus 2, t minus 2. Okay. And then over here, 5 I leave alone, but the bottom, let's see, I can factor out a common factor of 2. Oops. Okay, let's see. So I can pull out a 2 here, and I get t plus 6. Well, okay. So let's look at what we have common here. I have t plus 6, And then the missing pieces are these two, t minus 2 and 2. So the least common denominator is what's in common. Okay, t plus 6. I also need a 2, and I need a t minus 2. Yeeks. All right, so the first fraction, all I needed was the 2, so 3t minus 2 times 2. Minus, be careful, 5, let's see, on the bottom I need a 2t plus 6 and a t minus 2. So the thing I need here is t minus 2. All right, so now be aware of this minus sign. Let's do the first numerator. We're going to combine them together in one fraction. 2t plus 6, t minus 2. Let's distribute here. 2 times 3t is 6t. I want a different color. Negative 2 times 2 is minus 4. And then 5 times t is 5t, but it's a minus, so minus 5t. 5 times negative 2 is negative 10, but it's a minus, so plus 10. Okay, so combine your like terms. On the top, I got 6t minus 5t. That gets me t. And the numbers are plus 6. Oh, 2 t plus 6, t minus 2. Is there anything I can simplify? Well, yeah, fantastic. Get rid of those. So now what's left? I have 1 on the top because there's nothing else there. 2 times t minus 2. Done. It's not a terrible thing, but listen, watch these back if you're stuck. I do them a couple of times. Sometimes it takes practice to do math. I know, it's horrible. Pause, try this one. I know you can do it. All right, so let's try. We don't need to factor the top because there's no common factor there. The bottom, I need to multiply to negative 2 and add to 1. So negative, let's see, x plus 2, x minus 1. Okay. Can't factor the 5. I can pull a 3 out of here, x minus 1. So now what's the least common denominator? Well, it's x plus 2, x minus 1, because I need both of those, but I also need the 3. Ooh, bad math manners, sorry. The 3 should go in front, but I didn't have room. X plus 2, x minus 1. Remember, multiplication is commutative. Order doesn't matter. Okay, so look at the first fraction. What did I change? I added the 3. So 3 times 2x plus 3 minus, what happened here? 5, I added the x plus 2. Okay, that's all. So this becomes 6x plus 3 minus 5x minus 10 all over x plus 2, x minus 1 times 3 again. So combine the tops. Let's see, I get x minus, oh, you know what? 3 times 3 was 9, wasn't it? That should have been a 9. Ha! X minus 1 over x plus 2, x minus 1 times 3. So what cancels here? Well, x minus 1s. So that gets me 1 over 3 times x plus 2. All right, a couple million more of these. All right, this one has 3 parts. So think for a minute, factor what needs to be factored. Okay, look at just the denominators. I have an x, I have an x plus 3, and then this guy, I can pull an x out of x times x plus 3. Oh, there it is. So the common denominator in this case, I need an x for that guy, an x plus 3 here, and an x plus 3 here. That's my common denominator. So the only fractions that need to change are the first two. This needs to be x times x plus 3. So what changed in the first fraction? Just the x plus 3. Plus x times x plus 3. Let's see, it changed here just because of x. That actually just becomes x squared, right? And then the last one doesn't change at all. 3x plus 18 over x times x plus 3. Okay, so I'm going to just write myself a little note above this one, what it becomes. I want the green pen. All right, this becomes 2x plus 6. All right, so let's combine stuff. I get 2x plus 6 plus x squared, oosh, minus 3x, distribute that negative, minus 18. So that becomes, I'm just going to do the numerator right here, so that's all I have room for. That becomes 2, let's see, x squared. 2x minus 3x is minus x, negative 18, and 6 minus 12. So x times x plus 3. Well, sadly, the top needs to be factored. So let's do that. Multiply to negative 12, add to negative 1. That'd be x minus 4, x plus 3, writing right off the side here. X times x plus 3. There it is. There's our common factor. Okay. Ooh, sorry, my screen and I had a little problem. Chrome thinks I'm talking to it. Go away. So then I have x plus 4, or x minus 4, sorry, over x. All right. You try that one. I'm going to tell you that the final answer here is a plus 3 over a minus 3. I want you to see if you can get to it. Okay? Factor this piece, make your common denominators, simplify. This is the answer. See if you can get there. Let's do the last couple. All right, unlike denominators here. So this is an interesting thing, right? This is a strange little thing. But same as before, I can take the second fraction and change it because I can take out that negative 1. Okay, so then it's a common denominator, but negative times negative 1 makes a plus. So it just changes what we're doing. 6w plus 4 over w. That just becomes 10 over w. Weird, right? Try a second one. So factor out a negative 1 out of the first fraction here. So it becomes negative 1 times 3 over y minus 5 over y. Remember that the negative belongs to the whole fraction, so it can go in the numerator. So that's really negative 3 over y, minus 5 over y. Negative 3, minus 5 is negative 8 over y. All right, 2 more. Same thing, right? Switch the sign here. So this becomes, pull out a negative 1. Pull out a negative 1, negative y plus x, which is the same as negative 1x minus y. So we have our common denominator, but that changes this sign to a negative. So then I have common denominators. This is x squared over x minus y squared over x minus y. Now, make your fraction, x squared minus y squared over x minus y. And stop and think, can I simplify? Well, yeah, right? Top is a perfect square, or sorry, a difference of squares. So x minus y, x plus y. Bottom is x minus y. Cancel, and the answer is x plus y. Here's the last one here. All right, you try it. Your final answer should just be 3. See if you can make it work. Okay, so let's see. This second fraction becomes negative 15 over a minus 5. Okay, so this was a plus. It now becomes a minus. So it becomes 3. Ooh, that's a bad 3. 3a minus 15 over a minus 5. We'll factor a 3 out of the top. 3 a minus 5 over a minus 5. Ooh, there it is. My answer is 3. Okay, so this is the end of 5.3. I'm also going to do notes for the start of 5.4. Okay, so I'm going to do that in a second video though. So I'm going to end this one and then we will begin the next.